you use File, File, New, Start Atmel Project. When you do this, it will take you through a wizard to start the project. Comes up like this. You got to give it a lot of time, depending on the speed of your processor. This takes a while. The first thing it's going to ask you is, what is the target IC that you want to program? Atmel has hundreds of different processors. And depending on the capabilities of those processors, it might have more registers or fewer registers than the one we're dealing with. The opcodes can change from processor to processor. You compile it for the wrong processor, the program will not work. And I think Atmel Studio is actually smart enough to realize you're trying to send it to a chip that it won't work on. So at least it saves you that. For the Arduino board, we will be using the 18 mega 328P-PU, but all you have to do is type in 328 into the filter box. If you click on it first, it does help. And most of the time, it's the 328PU. I got it slightly wrong, but I know that's the right one. So you click on that guy, make sure it's highlighted. Also, because we do not have a screen or anything hooked up to this guy, the only way we can get output is if we tell it we're going to use the UART, which is the RS-232 over USB. So we're going to say we want one UART. So you gotta select this, you gotta select this. The other ones we might select from time to time as we get into the other hardware control of the Atmel chip. But those are the two you need. For now, you hit Create Project, and it's going to sit there and do some stuff and get into this window. This window is saying my project, I have one UART, and my CPU control. We have to do a little hardware setup here. It makes our life easier. For the CPU, the Atmel chip has a clock on board. It is an 8 megahertz clock. But the Arduino board overclocks the chip to 16 megahertz. That is the clock crystal right there. So instead of using the built-in one in the chip, they're using a hard one outside. So we have to tell it we're actually overclocking. So we have to change that from 8 megahertz to 16 megahertz. If you don't do that, the UART won't work. And anything else associated with time will be all messed up. So make sure you do that every time. The other one is the UART. If you want to use printf, you must check mark there, or else it will not include the printf instructions, even if you put in stdio.h. So make sure that if you plan on using printf, you check mark that. You also want to know the baud rate, the bits for the dumb terminal, because you're talking over a terminal, you have to set up the terminal on the other end to communicate with it. We'll be probably using PuTTY. If you use that program at all, It's a dumb terminal that also has internet capabilities, but it also can be used for COM ports. It's a very small program. You can put it on a thumbstick and run it anywhere. Very useful, but you have to do it. All the other check marks and everything else, it says what pins we're going to use, that sort of thing, and it actually comes out and talks to the hardware on the board. So we have to do those, but they're all defaulted. And then when you generate project, it's going to sit there and create a blank project. So it's going to ask you for a name. I'm just giving it a name. Notice the project name and the solution name follow each other. By default, it puts it on my documents at Atmel Studio 7.0, but you can put it anywhere. It might give you this. I think it's a update issue, but I don't, so far it's been working for me, so I'm sticking with it. It goes through and does a lot of stuff. It's putting in the UART information for me. It's putting in that Atmel start. It puts in main C. It puts in that. If you notice, the output files we were looking at in the other project aren't there now because we haven't compiled yet. All you have to do is click on main C, and voila, we have the Atmel start init that you need in every program. You have the while. You do have to include stdio if you want to use printf, but now you can start programming. I don't have the program off the top of my head. When you're done with the program, you can do build solution. And down here, it's going to let me, yeah. You're going to see when you do a build, it should say 1 succeeded, 0 failed, 0 skipped. You should have 0 errors, 0 warnings. Once in a while, you might have a warning. Warnings still say it compiled, but there's something a little fishy with your code. For example, if I do so this is giving me one warning, and it's telling me unused variable A. I didn't use it for anything. Why did you declare it? It's still compiled. I still have output files, but it's just giving me a warning. Something's a little fishy in your code, but it's legit and still can be sent.
Now, does it tell you which line too?
If you click on this, it should take you to the line.
Right.
So, and it also tells you the line number, but I still haven't figured out. I'm sure there's a way to turn on line numbering over here somewhere, but I haven't looked for it. Let's take a quick, it's probably in view, but I don't know. Line numbers, line numbers. I don't see a line number thing. It's probably an option there somewhere, but I don't know where it is yet. I've only been using Atmel Studio for about 1.5 years now, so. Lastly, most of the time now, we would take that hex file in output, go over to a burner, pop a chip in, plop in the hex file, send it to the chip. But we have an Arduino. So we are going to use that same USB cable to send programs. To do that, it's a little funky, because you actually have to tell Atmel Studio how to do it. The procedure is on my website. down here. You have to actually set up a macro. It's not completely there, but the strings you have to type are there so you can copy paste. The way to do it, mine are already done, but I'll go through it anyway. You go to Tools, External Tools. If you do not have Tools, External Tools, you are in the wrong setup, and remind me and I'll go back and show you how to get the right setup. I'm going to add a blank one so you see what it's going to look like for you. You hit Add, you give it a name. Upload to Uno in this case. And then you need the strings off the web page. This first one is pointing to a program. Program files, x86 Arduino hardware tools, AVR bin, avrdu.exe. This is why you install Arduino on the same computer you're installing AVR Admel Studio to. That is the only program from Arduino we use. That is the program that sends the bin file. So you are saying, there's the program, and then you're saying you're sending it to an 18 mega Arduino, what COM port, what speed, you're sending it to flash memory, and then you're pointing to the hex file in your project. That's what the second line, the second box does, the arguments. So you actually have to copy this in to command. You have to copy that other big long line, including the quotes and everything else, into the second line. And then you have to make sure you change the COM port to your current COM port. If you don't know how to get COM ports on, figure out what COM port you're on. With the Arduino plugged into the computer's USB port, in Windows 10, search for PowerShell, which I've already done, but I'll do it again. So you search for PowerShell. There it is. You execute that. You copy everything within the quotes here to here. Hit enter. And that tells me my Arduino is hooked up to COM4. So I have to change that to COM4. Leave all the other numbers, everything else the same, but you do have to change that COM port. Every time you plug in the Arduino, you have to do that, because if you plug it into a different USB port on the computer, it changes. If you have a different Arduino board, it changes, or it can change.
But if you plug it on the same USB.
Same USB, same Arduino board, it should go to the same COM port. Should. But if you move it to another computer, it might change to a different COM port.
Right, it will.
So you always have to change it, and I have not figured out a way to automate that process yet. When you do that, you apply, and that saves it, but it does not save it to those computers over there. But there is a trick I've just learned, but I have to write the instructions out. Yes, the instructions are available for most of this in the first lab. It steps you through all this if you didn't get all the notes. And the first couple times I will help you through this because it is new to everybody. So I'm not throwing you the wolves, I'm just giving you a preview that on how to do it for today. I have figured out, last semester we had to do that every single class because the computer is reset and the file it stores in, but I've now figured out how to at least store that stupid file to your thumb drive and retrieve it.
What if we use in our
If you use your own computers, you don't have to worry about it. And There's some other benefits to using your own machine as well. Some setup stuff you can do that you can't do on the computers here. But now when you go to tools, it'll show up in this menu. So there's upload to Arduino. You must make sure you build before you upload. You don't build, even though your code changed, the machine language hasn't changed, you're sending the old code. So make sure you build, then send. Build, then send. In this class, and in most microcontroller classes, it happens at least once a year. You get frustrated, you're trying to do something quickly, you forget to build it, you keep on sending the old code, going, why? I know I fixed that, why isn't it working? And you spend the next 3 hours debugging code, and the only reason your code isn't working is because you didn't compile and send it to the board. So make sure, build, send, build, send. Make it an automatic thing that you always do. Build, tools, upload. You'll see something like that. If it only flashes for a fraction of a second and you don't see half a screen full of text, that probably means your COM port is either in use or it's the wrong COM port. So for example, if I'm going to use my COM port, it was COM 4, right? So I'm using my COM port now. If I try to send code, it didn't even blink. That's an indication that your COM port's in use, it didn't send the code. You have to see that full screen of text, and actually if you go in here, external, if you do this, apply, I believe that is the magic button that it now, oh, it's putting it down here, but now you can actually see that it actually, if you are done, thank you, that tells me it sent it correctly, and that program is 354 bytes. And most of that is just C overhead because there's nothing in that code except the log. That code does nothing. For the most part, this is C, ANSI C, just like you learned in 1211. If you still have your 1211 notes, you might want to start taking a look at them because we will be using those same commands. What's this class over? 815? Why not? So I have a basic shell of a program. I'm going to include stdio. Printf works the same way. So this is your standard hello world in microcontrollers in high-level language. So I'm going to build it. I'm going to send it to the board. And now, to see the output, I have to use a dumb terminal program. So I am using PuTTY. Serial port 9600 baud is the speed. We gave that to the Arduino when we set up the board. I have to tell it COM 4. Oops. So why did I type a 5 instead of a 4? because that's what it was earlier today. Hit open, and when the program runs, anytime you connect to the serial port through the UART, it actually resets the board back to the beginning of the code. So it's printing hello world forever. And if I reset the board, the program automatically runs. If I disconnect the board, of course, the terminal is going to disconnect. But when I replug in the board, repower it, I have to reopen my dumb terminal because it lost the COM port. But even when I remove power, it goes back in because that command line said flash. The program is being put in flash memory, which is not erased when power is lost. So this Arduino, next week, next month, next year, you power it up, it would start saying hello world again.
Now, what was the NR stand for? I forgot.
/n/r is carriage return line feed.
Oh, yeah.
So carriage return takes the beginning of the line feed takes it down one line, so it isn't overwriting itself. We're not writing side by side.
Okay.
If you don't put those in, it would say hello world across the screen. Then when it got to the end, it would come around and keep on doing that, but it would fill up the screen that way instead.
Right. Yeah.
Oops. What will this program do?
We printed about 10 times, right? Only? Distance. Oh.
So I printed it 10 times?
No, as long as it's A equals 0. Yeah, 10 times. No, 9 times. 9 times, I think.
Let's find out. I think I signed it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 through 9, 10 times.
0 to 9.
Because I started A equals 0, then A less than 10.
Right, okay.
So you remember something about a for loop, declaring variables,
Some.
stuff like that. And again, I did that outside the while, then put the program into an infinite loop, but it does nothing. So once it does the 9 hello world, it goes into a loop and just sits there dumb and happy and wastes time until the end of time. All the basic C functions do work to some degree or another. You can do math, you can do that. I will warn you, this gets a little weird. Okay, whoops, wrong window. Yeah. Oh, ooh, don't get rid of that. Okay. Hello? What's this gonna do?
It's gonna divide A over B. And,
The percent sign something.
that's not the last one.
That's a placeholder for a integer. Percent I, remember percent I for integer, percent F for float. So it's going to divide forever. What's it going to print?
It's gonna print 3 only.
Yeah, we'll just take 3. It could do decimal because it's on floor, right? Yeah. That's I agree with you. Yeah.
Again, we're doing integer math. So 10 divided by 3 is 3.33333, but it can't do the math because it's integers only. What's this one going to do?
3.3. 3.8.
3.3 forever.
Okay.
Yeah,
3.3333333333333.
Will it ever return?
Question mark, question mark, question mark, question mark. Be aware of this, it will hit later in the semester. The check mark for printf only turns on integer printf. It can do integers, it can do ASCII characters. It cannot do floating point. There is a procedure on the website to turn on floating point printf. But floating point printf, this was printf, floating point printf, double it. So most of the time we don't use floating point numbers in embedded systems because of the fact that it takes up so much memory. Again, memory is a lot cheaper than it used to be, so we can get away with it. I remember I did a project on an older microcontroller called the 68AC11, and I found a library to do floating point math. I couldn't do anything else in the program because the floating point math took up all the floating point library took up the entire memory. That's how big it is. So they shut it off by default, and you actually have to go in there and change the way it compiles to include printf for floating point.
we don't have to do that here, right?
We will do it from time to time. If we want to do integer floating point math for some reason, we will do a couple of experiments where we do want floating point math, so we will turn it on at those times. And that's when get floating point values, this is how you do it. But if you ever see the question mark, I'm showing it to you now, so if you see that stupid little question mark come up from ever, and you go, my math's right, why am I getting a stupid question mark? That's the reason why. You're trying to print a floating point number without floating point library installed.
So it show up only for floating, or there's any other occasion?
It's the only time I've seen it so far. In this one, if you see, it includes, this is basically use vprintf library, which is vprintf. That includes the floating point. Ifs, all your loops, all your math does work to a degree. Again, if you try to use, I don't know if you ever use math.h with like cosine and stuff like that. You can use it in Arduino, but again, you're starting to suck a lot of memory because you're using floating point. But math.h does exist as a library. You probably use that in 1211 if you took 1211. But most of the time, we will just stick with stdio.h. And the only reason we include printfs is for debugging purposes, and then we take them out when the Arduino is doing what we want it to do. Unless we're trying to do something to print to a terminal. But most of the time in embedded systems, you either print to an LCD, and we'll fool around with LCDs partway through the semester, I hope. But a lot of times we're controlling something, again, the microwave oven sort of thing. Your mouse probably has a microcontroller in it to send the signals from the encoder to the computer, that sort of thing. So it wouldn't hurt to start looking through the cheat sheet for C. I have it here. This is the cheat sheet I use for C. Main, declaration statements, functions, preprocessor directives include define, data types, char, int, float. You will start seeing some of these other ones, signed, static. You will probably see some of those in the Arduino. How to initialize a variable in an array. We will use arrays at some point, but I know probably if you did anything in arrays in 1211 at all, it was very slight. So if we do use an array, I will go through it much more carefully. But arrays in this class make a little more sense than they do in C. Did you ever wonder why arrays start at array value 0? You know, like when you put stuff into an array, it was A, 0 was the first thing in an array. That's pointing, this is pointing to a memory location, and it's saying offset 0. So it's actually using memory, the way we arrange things in memory. It's actually, this is the memory location where I put it. Start putting the values in. This is the offset into the memory. Makes a lot more sense that way than trying, that explains the 0 to students a lot better than just trust me, it's 0. You don't start counting at 1 in C, you start counting at 0 because it's a 0 offset in memory. We'll use constants a little bit. We will deal with pointers, but most of the time it will be hidden. But you probably never even heard of a pointer in C in 1211. You might have used one without knowing it. The ampersand in scanf is a pointer. We just never explained it. A pointer is the memory location of, so it's the address. So it's using addressing instead of the variable name. That's what pointers are in C. Again, makes more sense in here than it does in C because you don't even know what a memory location is.
Scanf. That's like when it's waiting for an input from a keyboard?
Yes.
Okay. Yeah, I remember.
Now, I'm not 100% sure scanf works over the terminal, but I've never tried it because I never use it. It would be interesting to try it, but I've never used it. Standard operators, but I will warn you now, we will be using a lot of the ones you haven't used before. You've probably used addition, subtraction, multiplication, division. We'll use those from time to time. But we will probably be using a lot more bit operations and or nots than you're used to. Because in this class, we can sense the special memory locations in the Arduino to set up hardware. We can actually tell hardware to do things by setting up bits. And we use and ors to set those bits. So we do that quite often in the Arduino programming, so you'll be using the bit operations more often in this class than you have. So just be aware of that. We will not do too many strings, other than maybe hello world, and some stuff to an LCD display, for example. That's the only time we use strings, characters. Flow control, you should know. If else, while loops, for loops, do while loops. You should be familiar with those. And we might use a switch statement here and there as well, if you remember any of those. We will not use too much standard I/O, file I/O, although we could use file I/O, I think. I'm not planning on doing it. We might need standard utility functions from time to time. But most of the second page, we won't be using much of the second page. Most of it's on the first page. So start reviewing. Again, I do understand it's been a while since you've used C. So when we come up to an instruction you haven't used before, etc. The thing is, in this class, a program this much does a heck of a lot more than in any other class. Because I can define a whole bunch of hardware and do a whole bunch of things in that much code. And when we start doing the actual programming of the chip itself to do things, the hardware takes over from a lot of the coding that we would have to do on a normal processor, because this is an embedded system. So as I said, this week we're going to look at a compiled C code. You're going to do something similar to the bits to show you understand a little bit about how the machine language breaks down into bits to set up functions. This one's going to take some time. Please make sure you have the software installed so you're not waiting 20 years to install the software before you can even get started. I will supply the text of the code, but you will have to copy and paste it into a project you started. So I'll give you main, but you're going to have to copy and paste it into the project shell. One last thing for the evening. In this class, I will ask you most of the time to submit your code. When you submit your code, you have to submit the entire project. If you don't, I don't get the hardware configuration you set up, etc., etc. So it won't work if you just send me main. I have to set the project up and put it in the main, like what you're going to do in class. If you send me the project, I get everything. What is the difference? Here is the first, this is the project of the first program I ran today. This is the one we looked at in machine language. It is a directory, not just a file. If I go into that directory, I have this Atmel Studio file here. I'm actually going to turn on It's actually an ATSLN file. That is the one that defines the project. All these other files are the project themselves. So when you submit any assignment for this class, you go up one directory till you see the directory. And then you make that into a zip file by right-clicking, send to, compress zip, and send me that file. That gives me the entire contents of the directories. So here, in class, there's my main C, but look at all the other files and all the other directories that support main.c. If you just send me this, or don't send me the project file in the directory above it, it takes me hours to load a program instead of minutes or seconds. So please make sure you zip it correctly before you submit it to me. If you just want to quickly look at code in a project, you can go in here, and I use, where's my Notepad++? There it is. You can actually look at main.c as a text file without damaging it. So that's the code without all the support, but if you don't send me everything, I have to start from scratch defining the chip, defining all the speeds and everything else. So please send it to me as one big thing.
Once we do the lab on Thursday, you think this will start making more sense?
I'm hoping
The
so.
KKK and all DDDD, all this stuff?
All the day, and really and truly, I want you to get a sense of that, and it will be on the first test whenever that is. I will have you do a little hand compile, not a big one. I just want you to have a sense, so when you see a data sheet like that in the future, you understand what it's trying to tell you, because even like in PLCs, there is a programming language in PLCs other than ladder logic, and it will look vaguely familiar to that DDD, RRR stuff you see here. It will look like opcodes. What is it? NOC is a normally closed contact, and then you give it the contact number, I think is the way it goes in the text version of ladder logic. You probably won't see that in PLCs 1. I think he's doing that in PLC 2, but I could be mistaken. But some of these things will start making sense. Ports and robots will start making sense when we start dealing with I/O pins. They'll start making more sense in the robots as well. So, but hopefully you'll get a sense of how things are stored in memory and stuff like that on this experiment. But then we're going to really move on to C programming and starting to actually do things with the Arduino. First thing we're going to do is turn things on and off using the program. And then we'll start building up from there, going through the facilities of the Atmel chip. Because we have looked at we've looked at this over, I think. So ALU, general purpose registers, status and control, program counter, flash memory, instruction register, decoder, and control lines. We've dealt with that stuff. That's the CPU stuff from the Scott processor video. But then we're gonna start, and we've talked about RAM, EEPROM. We haven't done I/O lines, and we've done nothing with the I/O capabilities of the chip. And that's what the rest of the semester is gonna be, is actually controlling stuff, measuring stuff, bringing stuff into a processor to do something with it. The fun stuff.
My whole entire brain hurts.
This is a lot of information. It really is. But I'm hoping you're starting to see a little connection between memory
It all makes sense, yeah, it's just a
and
lot.
so on, but it's a lot of stuff. It is a lot. And trust me, this is the abridged version. This manual is how many pages long? Uh, 662 pages, plus the opcode, which is an additional 191 pages. There's a lot of information for just such a small little block of silicon. And there's still more data sheets I haven't downloaded. Those are the two important ones. I will see you in class.